In this video, we are going to look at solutions to the review for exam 2, starting with number 50. So on 50, it says a nightclub owner is trying to arrange 9 acts for a show. There are 5 musical numbers and 4 comedians. In how many ways can the show be arranged if the acts can be arranged in any order? So for this problem, we're not looking at probability. It just wants how many ways. Okay, my cursor was stuck. How many ways? So this is just accounting. And since order matters, we're choosing 9 from 9 acts for the first act. For the second act, after we've chosen one of those, there will be 8, and then et cetera, et cetera, et cetera. So this is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, or that's the same thing as 9 factorial, which on your calculator is also the same thing as 9 with a permutation of 9. So you're choosing 9 things out of 9, and all of those calculations will give you the same thing. Let's see what that is on Desmos. So if we hit 9 and want to do factorial, you have to go to functions, and then it's this exclamation point. You can see our answer is 362,880. Or if we did 9p9 down here, so p of 9 things chosen 9 at a time, you can see that gives us the same answer. So it's 362,880 for part A. So in part B, here's where, again, they want how many ways the acts must alternate between musical and comedians, starting with a musical number. So if there are 5 musical numbers and 4 comedians, that means for the first choice, you can choose from the 5 musical numbers. For the second choice, there are 4 comedians to choose from. For the third choice, we're going back to musical numbers. But since we already chose one, there are now only 4 musical numbers to choose from. And then we're going to alternate. So now we're going to the 4 comedians, but we already chose one comedian. So this would be 3, et cetera, et cetera, et cetera. So for this problem, we must alternate. And it was 5 times 4 times 4 times 3 times 3 times 2 times 2 times 1 times 1, that's 9. You can count them. Multiplying it out, we get 2,880 possible orders. Now, the last one says the show must open and close with musical numbers, but the remaining acts may be in any order. So musical numbers, that means there are 5 for the first number. And then if you're choosing from the musical numbers for the last one, there would be 4 to choose from. Now, for the remaining numbers, it does not matter what they are. They could be musicals or they could be comedians. Now there are 7 positions left. So this is just going to be 7 times 6 times 5. We can combine them because it doesn't matter what they are. So if we take 5 times 7 times 6 times 5 times 4 times 3 times 2 times 1 times 4, we're going to get our solution to part C. When we multiply this out, we get 100,800. Let's go to problem 51. 51 asks, in how many ways can a 2-card poker hand be drawn from a standard deck of cards? Now here, order does not matter. So since order does not matter, in how many ways? It's going to be, there are 52 cards to choose from, and that'll be choose 2, which if we use the formula is 52 factorial divided by 52 minus 2 factorial times 2 factorial. We could do it that way, or we could go over to Desmos and see what we get. Let's try that. So the combination thing is right down here when we go to functions. So we do that, and then it was 52 choose 2. Looks like the answer is there are 1,326. So it looks like there are 1,326 two-card poker hands. Let's keep rolling. Here it asks or says the science club consists of 18 men and 12 women. 5 members are chosen to staff the club's booth at the Science in the Park Festival. In how many ways can the members be chosen if? So again, this is just in how many ways. And here order doesn't matter. It doesn't matter if we chose Ben first, Carl second, and David third. We're just choosing them. So from the 18 men, we want, 18 men and 12 women. So that means there are 30 possible people to choose from when we add 18 plus 12. Now, if you want any of the members can be chosen, that'll simply be 30 choose 5 because there are 5 members. Let's see what we get if we do that on Desmos. 30 choose 5, we go to functions and down here, and then we go back to main and go 30, 5. Looks like our answer is 142,506. Part B asks, it wants all 5 of the members to be women. So if there are 12 women, that would be just 12 choose 5. So let's see what that gives us. Looks like Desmos says that 12 choose 5 is 792. Part C asks, how many ways can 5 members be chosen if exactly 3 are men? So first we have to take the men, which would be 18 choose 3, but that means 2 of the women will be chosen also. So that will be multiplied by 12 choose 2. Let's see what that gives us. It looks like 18 choose 3 times 12 choose 2 is going to give us 53,856. Let's move on to 54. 54 says a theater club has 14 female and 9 male members. 2 members are selected at random to do an acting exercise. What's the probability that both are male? So the way we do this, since it's probability, this means we have to have a fraction, right? So if we want the probability of both male, that'll be the total number that are male divided by the total ways you could pick any members. So if there are 14 female and 9 male, that means total 14 plus 9 is 23 total members. And we want to choose 2 for an acting scene. So for our total, it's going to be 23, choose 2. In our numerator, we want just the male. Since there are 9 males, we're going to go 9 choose 2. And that fraction is going to give us our answer in probability form. All right, so when we do this on Derivida, or I'm sorry, Desmos, we do 9 choose 2 divided by 23 choose 2, we get 0.142, or reduced fraction of 36 over 253. So we write that down as our solution, and that's what we have. Let's look at number 55. The science club consists of 18 men, 12 women. 5 members are chosen to staff the booth at the Science Park Festival. What is the probability that all 5 members are women? So again, for probability, all 5 women, that's the number of ways we can choose women over the number of ways we can look at the total. Now there are 30 total. If we do this calculation, that'll give us our solution. Punching this into Desmos, um, we got 44 over 7917 as a reduced fraction. And as a decimal, we'd round that to 0.006. Now, the part B wants that exactly 3 men are chosen. So the probability of 3 men is going to be, there were 18 men. So this would be 18, choose 3, divided by, oops, if we choose 18 men, we still have to choose 2 women. So that'll be multiplied by 12, choose 2. And then that'll be divided by that 30, choose 5. Let's see what that gives us. Desmos tells us that would be a reduced fraction of 2992 over 7917, or 0.378. We'd round that to 0.378. Let's look at number 56. In 56, we see that it says, a barrel contains 20 good peaches and 4 bad peaches. A person selects 3 peaches at random. What is the probability? So once again, it's probability of 3 bad. So order does not matter in these instances. So again, if order mattered, then we'd be using permutations instead of combinations. But order doesn't matter. So 3 bad, there are 4 bad. So there would be 4, choose 3 in the numerator. And then, let's see, there are 20 good peaches, but you're only choosing 3. So it's going to be divided by 20, choose 3. Let's see what that gives us. You know what? I made a mistake. Choosing 3 bad peaches, there are 3 bad to choose out of 4, but our total number of peaches should be 24. So down here, instead of 20, I should have 24, choose 3. All right, if we do that calculation, Desmos tells us it's 0.0019, which we're going to round to the third decimal place as 0.002. Now we want the probability of 3 good peaches if we're choosing 3. So that's going to be the good peaches, or 20 good peaches to choose 3 from, divided by 24 total to choose from. Let's see what Desmos tells us that is. All right, it looks like Desmos is telling us that's about 0.563, or a little bit half over half. Now we want 2 good and 1 bad. So we're going to have our denominator will still be the same, the 24, choose 3. But of the 2 good, you'd be picking 2 of the 20 good. So it'd be 20, choose 2 times 1 of the 4 bad. So 4, choose 1. Let's see what Desmos tells us that is. It looks like that answer would be 0.375. I hope these explanations were helpful, and we hope you do well on the exam. Thanks for watching.